Okay, so today we're going to run through section 1.1 uh, for Math 171. We're going to start out by talking about what a function is. So, in the natural world, you might see some relationships between quantities that can change. And when you see these relationships, you might ask yourself something like, if I know one quantity, can I then determine the other? So this establishes the idea of an input or independent variable and a corresponding output or dependent variable. We call this a dependent variable because it depends on the input. For some quantities, such as, let me find my mouse here. There we go. For some quantities, such as, say, for height and age, for a given person, there certainly is a relationship between these two quantities, right? So if you're given a certain person and their age, you can determine their height at that age. For instance, if you're given Mr. Shields and you're given the age of, say, 28 years old, that's how old I am, then you'd be able to say that I am 6'5". So similarly, well, we'll get to that in a second. If you tried to predict my age from my height, you might have an issue though, right? Because if I gave you that my height is 6'5", this doesn't just map to a single age, right? For instance, you could go back to when I was 18, and you'd be able to say I was 6'5" at the age of 18, and at the age of 19 and 20, and so on, right? However, a single age typically gets assigned to a single height here. Obviously, people can grow within a year and have a growth spurt, right? But just generally speaking here, you can determine someone's height from their age, but not their age from their height. If you know that person and you have, say, a sheet or a table of their heights and ages. So let's get right into the definition of a function. A function is a rule for a relationship between an input or independent quantity and an output or dependent quantity in which each input value uniquely determines one output value. So for instance, we could say that age is a function, or rather, blah, blah, blah. Height is a function of age. I could say that height is a function of age because each age uniquely determines a height. However, age is not a function of height. This is because a single height input might correspond to multiple ages. And again, there's a small issue in which, you can have a growth spurt during a year, right? And therefore have multiple heights throughout a year, but just this is in general. Similarly, if you're at a coffee shop, the price of an item at a coffee shop is a function of the item. Each item uniquely determines a price, right? There aren't multiple prices for a single item. In this case, we would consider like a large and a small to be different items, right? However, each item, or rather the item, is not a function of the price. This is because there may be multiple items that have the same price. I'll say 2 or more items can have the same price. So this kind of brings us into our next definition, our next small topic here. We talked about the definition of functions, so let's talk about what are called one-to-one functions. Sometimes in a relationship, each input corresponds to exactly one output, and every output corresponds to exactly one input. So each input corresponding to exactly one output makes this relationship a function. And on top of that, if all of our outputs also correspond to exactly one input, then we're now talking about a one-to-one function. So we often use what's called function notation to simplify writing out expressions and equations involving functions. So, for instance, rather than saying height is a function of age, we might use some descriptive variable for height and some descriptive variable for age. So we might use the variable h to represent height and the variable a to represent age, and say h is f of a. And here we're using this letter f to just represent a function. Or we might say h equals f of a. Again, this is just height is a function of age. Or if we wanted to name the function itself h, we might write h of a. We can use any variable to name this function. Sometimes it's just nice and convenient to use something descriptive or something that a letter that originates from the problem that we're talking about. So in function notation, let's say the notation output equals f of input defines a function named f. This would be read output is f of input. Let's see. Let's use function notation to represent a function that takes the input of that takes as an input the name of a month and gives as the output the number of days in that month. So this takes the name of a month as an input, and it outputs the number of days in that month. So we might start out by writing this as something like days equals f of month. Days, number of days is a function of the month. Or we might use descriptive variables and say replace days with d and replace month with m. So now we have d equals f of m. Or we could write d of m. And for instance, we could say d of March is 31. let's see. Let's look at tables as functions. So we can also represent functions as a table. We'll use the same month example at first. Here, let me grab a few shapes here. So I will create a table here. And in this table, we'll have our input, which is the month number. Which we'll call M. And our output will be the number of days in the month that we'll call D. So, for instance, if the month number is 1, that's January. This has 31 days. If our month number is 2, this is February. This typically has 28 days, although this year it had 29 due to it being a leap year. For the third month, that's March, we have 31 days. Then for April, we have 30 days. Then we have 31. Then, trying to keep my pattern up here. Sorry. Then we have 30. I'm going to go ahead and write in some numbers before I separate them. We have 7, 31, 8, 31, 9, 30. I'm actually running out of room here. 10, 31, 11, 30, 12, 31. I had just enough room for my table. Now I'll draw these lines. Since August and July both have 31 days here. So this table represents, well, we already talked about what this table represents, right? So this is that same function that we had previously written in function notation, except now instead of taking the name of the month as an input, it's just taking the number of the month as an input. So if you input 6 into this function, then you get 30 as an answer, because in the 6th month, which is June, there are 30 days. Let's look at some more tables. Let me make sure I have. There we go. We'll have input and output. 2 and 1. And 5 and 3. And 8 and 6. Now I need another table. I need 3 total. Here, I'll go ahead and get these vertical lines. There we go. Again, I need input and output. For here I have -3 and 5, 0 and 1, then 4 and 5. And for this last table, again I have input, and then I have my output. I have 1 and 0, then 5 and 2, make that look more like a 0, and then 5, and 4. So let's look at these tables and determine which of these tables defines a function. So which tables define a function? And are any of them one-to-one? So which of these tables define a function, and are any of them one-to-one? Let's see. Let's start out by looking at, let's look at this first table. So what we want to look at is, okay, the color of my pen didn't actually change. Maybe it will now. Okay. So what we want to look at is every output here assigned is every input assigned a unique output? So let's see. 2 is assigned an output of 1. 5 is assigned an output of 3. 8 is assigned an output of 6. So here, I don't see any inputs being mapped to more than one output. So as a result, this is a function. In this second table, I have -3 being assigned to 5, 0 being assigned to 1, and 4 being assigned to 5. So none of my inputs here are being assigned to more than one output. So this table would also be a function. And in this last table, let's see, I have 1 that's assigned an output of 0. 5 is assigned an output of 2, and 5 is assigned an output of 4. So notice here that my input of 5 is assigned an input my input of 5 is assigned an output of 2, and my input of 5 is also assigned this output of 4. As a result here, I have an input that's being assigned to more than one output. So this table is not a function. So now we have to go back through and we have to see which of these are one-to-one, if any of them. So to determine if something is a one-to-one function, it first has to be a function, which means that this last one can't be one-to-one because it's not even a function. And every output has to have a unique input. So none of my outputs in this first one, none of my outputs in this first one repeat at all, right? So because none of my outputs repeat, no output is being mapped to by more than one input. This is a one-to-one function. In this second table, notice that I have an output of 5 twice. And this output of 5 each time is being mapped to by a different input, right? Because of this, every output does not have a unique input, which means that this is not one-to-one. And again, this last one can't be one-to-one because it's not even a function. You have to be a function first. Now let's look at, let's look at solving and evaluating functions. First, we will use a table. So let's create a table. Oh, I did not mean to make it the middle one is typically what I choose here. Okay. So we'll have this table of values. And let's say that this table defines a function where q is equal to f of n. So here, we could say, let's see, let's evaluate f of 3. In order to evaluate f of 3, we simply look at where our input of 3 is, and we read out what the output is. So when n is equal to 3, q is equal to 7. So this means that f of 3 is equal to 7. We could also do something like, say, solve for where f of n is equal to 6. So solving for where f of n is equal to 6 means determining what input values, n, produce an output value of 6. So in this case, the input values that produce an output value of 6 are both 2 and 4. So I'd say n equals 2 and n equals 4. So this actually means that this would not be a one-to-one function, right? Because my outputs do not have unique inputs. Now let's look at graphs as functions. So often a graph of a relationship can be used to define a function. So let's create a shape here and let's draw a graph. Let's draw a few graphs and determine which of them are and are not functions. So here I'll create this and I'll create 2 more. I got a here I'll just oh, okay. All right, I'll just do one at a time then. So let's say so I'm not great at drawing these, especially on this tablet, but I am going to try my best. It's not quite how I wanted this to go. Okay. All right, I'll draw these arrows here. So I guess first, let's look at this graph. This is a graph of some cubic function. So is this a function, and is this one-to-one? So let's see. Do I just have to swap it here? So is this a function, and is this 1-to-1? I guess I should have clarified here, of course. The horizontal axis here is my x-axis. This represents my inputs. This vertical axis is my y-axis, which represents my outputs. So is this a function? Well, yeah. So none of my inputs are being assigned to more than one output here, right? For every x value, there's exactly one y value, although maybe my drawing isn't that great, so maybe it doesn't quite look that way to you, but that was at least my intention in drawing this, I promise. This would be a function, especially if you drew it correctly. Sorry. Now, is this a one-to-one function? We would say that this is not a one-to-one function because I have outputs that are repeating. I have the same output that's being assigned to more than one input. For instance, where this crosses this x-axis, it crosses it 3 times, meaning that I have an output of 0 3 times on this graph at the red dots that I created. So this is not one-to-one. Let's look at another graph example. This one will be easier because I can use the straight line tool to help me here. For this graph, is this a function? And is this one-to-one? So this graph is a function because every input here is being assigned exactly one output. As I look across the graph here, I don't see anything being assigned more than one output, right? None of my x values are assigned more than one y value here. And is this one-to-one? So do I have any y values that are mapped to by more than one x value? No, I don't. So that means that this is one-to-one. And for another one, let me change back to blue. There we go. Oh, I didn't mean to change the actual thing itself. There we go. Now I have to use ink to shape, I think, because there's no actual circle thing. So what about this graph? Is this a function? Is this one-to-one? So in this case, this is not a function because, for instance, if I look at my x value of 0, see my x value of 0 is being mapped to a y value down here. And my x value of 0 is also being mapped to a y value way up here. So I have an x value that's being assigned to more than one y value. That makes this not a function. And because this is not a function, this means that this can also not be a one-to-one function, right? So let's look at some other ways of identifying whether or not a graph is a function and whether or not it's one-to-one. We have these nice tests that we can use. We have the vertical line test, For the vertical line test, let's imagine drawing vertical lines through the graph. Where was I? If any of these vertical lines, if any vertical line would cross the graph more than once, then the graph does not then the graph does not define a function. And it does not define a function because I have an input being mapped to more than one output in that case. I have another test I can also use that's called the horizontal line test. Instead, we imagine horizontal lines through the graph. And if any horizontal line would cross the graph more than once, then the graph does not define a one-to-one function. So let's look at maybe an example of looking at a graph and evaluating some things from a graph. Let me see if I can pull up a graphing calculator. So let's look at the graph that I'm about to pull over here, and let me go ahead and write what I want for us to do with it. I want for us to look at this graph and evaluate f of 2 and solve for f of x equals 4.